Okay, so what is a mineral? These would be good test questions to know. You don't have to memorize them, but you need to recognize the five. So if I throw you seven, pick out which five it would be right. So to be a mineral, it has to be inorganic. That is not made from anything alive. It has to be naturally occurring. That is made by nature, not humans. It has to be solid. That is at room temperature, it's not a liquid or a gas. It has to have a definite chemical composition, so it's always made up of the same set of atoms. And it needs a repeating pattern. In other words, those atoms will arrange themselves in a specific order, such as a cube if it's halite or pyrite, but an octahedron if it's fluorite or a diamond, or a rhombohedron, that is a long rectangular prism with nice sharp 90-degree corners, which would be calcite. A six-sided prism in the center and a six-sided pyramid on both ends is quartz and amethyst. Or a six-sided platy, which would be like mica. This is mica. You can tell it's got nice flat, breaks in sections that are flat. There is no pointy ends here except maybe where it breaks on these corners, but not on the edges they grow, so nice flat planes. All right, so how do minerals form? Well, you've watched a video. This is just a really quick review. But basically minerals form when magma cools. Hot molten material underground start to cool and crystals start to grow. Minerals dissolve in water and then slowly evaporate. This is another way. This is like a geode. And a geode is like this ugly rock, but if you crack it down the center and open it up, it might be just full of beautiful crystals. And really what a geode is, it forms when you have a gas bubble, maybe, let's say, in this magma as it cooled, or underground. And you can also get like calcite or things like that as they percolate through could fill in this. It honestly depends on what kind of geode you have. If it's an amethyst, it's going to form down with lava. But you get this beautiful crystals if you crack it open. Oxygen and silica are the two most common elements in magma. So, mineral properties. There are hundreds of minerals named. In order to tell one from another, we need to know the physical properties. So, for example, the color of the mineral. But the color of a mineral can be deceptive because fool's gold, pyrite, looks like gold. But if you look down here, the streak, that is when you scratch it onto like a porcelain plate. Cinnabar looks black, but it scratches like cinnamon, like that orangey brown. Pyrite looks like gold, but it scratches black. In fact, in class, what we do is we scratch it and we can figure out if it's gold or pyrite. Here's a hint. It's pretty much always going to be pyrite because I'm not having you scratch gold flakes off, just because that's a value-added thing. So color of the mineral itself, but then the color of the streak when you scratch it, what's left behind. So color and streak both use color, but one is the color of the mineral, one is the color of the streak when you rub it off. Luster, the way the mineral shines. There are only two really ways we classify luster, either as metallic, shiny metal, or non-metallic, pretty much everything else. Hardness, how resistant it is to scratching, and we use something called Mohs hardness scale to figure this out, where talc has a hardness of 1, gypsum has a hardness of 2, your fingernail's about 2.5, so it's between gypsum and calcite. So your fingernail would be able to scratch gypsum, but your calcium could scratch your fingernail. So we don't really ever use our fingernails to figure this stuff out because we don't want to, scratch them up. A copper penny is about 3. And by the way, your hair is also about the same hardness as copper. So that's why people who cut your hair have to get their scissors sharpened because it actually has quite a good hardness. It's hard on scissors to cut that. Fluoride has a hardness of 4, apatite 5, potassium feldspar 6, quartz 7, topaz 8, corundum 9, and diamond, the hardest thing we know of, is 10. So what we do is we have a little set with all of these 10 different things on there, and if it can scratch the mineral you have, you know it has to be less hard than that mineral. So let's say fluorite could scratch it. Well, then it has to be less than a hardness of 4. But let's say fluorite can't scratch it, then we know it has to be more than 4. We can use that with a penny. So sometimes, a lot of times in the labs, what we'll do is we'll actually have you scratch a penny. If we can scratch a penny, we know it's harder than 3. If it can't scratch a penny, we know it's less than 3. Cleavage. I know everybody's giggling, but the cleavage is how something breaks. And if it breaks in flat lines, that's called its cleavage plane. Other properties such as magnetic. Is it attracted to metal objects? Will metal objects stick to it like a magnet or not? So magnetic or non-magnetic. Acid test. Basically, it's calcite. If you put acid on it and it starts to fizz. Here's a drop of acid, and if it starts to fizz, that means it's got calcium carbonate and it is reacting with acid. It's releasing gases. It's having a chemical reaction. So we can do something like that. So these are the characteristics. When we're looking at it, we're looking at the color of the mineral. We're looking at the streak of the mineral, the luster, metallic, non-metallic. We're looking at how hard it is. Does it break in clean planes? Is it magnetic, and or does it fizz with acid? These are just some of the basic tests that we can do in class. Here's a little more if you want to get into the actual crystal shapes and how the atoms arrange themselves. And these are just some examples of hexagonal rings, that is six-sided rings. Here's a single tetrahedron, and you can see examples of then what that kind of mineral looks like when that crystal grows. We also have silicate and silicate polymorph minerals, sorry. And you can see some other shapes as things grow here too, and kind of how that framework blends itself. So you can see minerals for this going off in different directions. Feldspar is a little more chaotic. It's not quite as nicely oriented. This is basically minerals and ores and how you extract ores. If you want to go back into the notes, there's always reference at the bottom of this day's page, and you can watch that video if you want, but I'm not going to do that here because it's really hard to hear through Edpuzzle when I redo a video. If you have questions, as always, you need to just simply ask.